Hello everyone, welcome back. So in today's video, we are going to discuss map indexed functions. Uh, Again, the prerequisite is the same: class hierarchy of JDK collection APIs, extension function in Kotlin, and iterable interface. So in last video, we already discussed how the Kotlin under the hood implemented these map functions. So today we will focus on how they are implementing this map indexed. Before jumping in, only we can understand what is this function or what is the difference between a map and map index. So in simple words, map indexed, in this case, we are able to get the index value of that specific mapping object. For example, I can create a transform. In this case, index, which is always integer, and then for example string, and I'm expecting to return string. So my mapping is basically format change, and I'm saying okay, index and maybe name, and then what I need to do, I want to do name plus space plus index. So I will change the format. Now I give this and it will return, and we can show. So now you can see my list is a AB3, and in this case my A is index 0, index 1, index 2, and we can see after this implementing this transformation on that list, we got a new list which is A0, B1 and 3, 2. Basically 3 is the value of a list and 2 is the index. So now we can jump in and we can understand more how they implement it. So map.indexed returns a list containing the result of applying the given transform function to each element and its index in the original collection. And how they implement it, so it's same just like we discussed in a map. There is no difference except this index. Everything is looks like the same. The T is the data type, generic type of the list on which we are going to iterate. R is the return type. So in this case, this is the extension function on iterability, and then map indexed, and it's expecting the lambda and then returning a list of R. Under the hood, what they are doing, they are calling a mapIndexedTo, and which is expecting what, an array list, which is a new array list and a transform, and then we are again calling collection size or default. So if you guys remember, in last video we already discussed this method, but I can repeat. So in this case, this what is happening, it's saying okay, check the iterable interface. If method call is called on a class which is extends from the collection, then get this size, otherwise get the default value. So here maybe we can spend, so basically in case of a iterable function, these extension functions are all implemented on a iterable, but iterable is a generic interface. It's not like there is no constraint, you can only implement this iterable on a class which extends the collection. For example, I'm giving the same example which I gave in last video. So I'm saying you should do iterable of, for example, string, and then now in this case, if I create a variable or object of library, I am allowed to call mapIndexed. So in this case, why I'm allowed to call, because mapIndexed is a mapIndexed is extension of a iterable, and we know by default list extends from the abstract list and extends from the, like in between there are 3-4 classes, and then there is a iterable. So iterable, collection, blah blah blah, and then list. So that's why that list can access this map function, because it's extended from the iterable. But in this case there is no list, but we are implementing this iterable. So that is the also power of the extension function. Now in this case, when I'm calling this map index, what will be the result, because it's not a collection. So I hope now you will understand. Once that is not a collection, it will check if this is collection. No, it's not collection API, it's not extending from the collection API. Then what I need to do, give the default value, and if it's a collection API, then get the built-in one. So if I try to do this collection, in this case size is by default available. Now we need to implement, but now in this case if I call this method internally, it's going to call this, and then this is collection, yes, it will call this dot size. So now coming back where we are, so I hope things are clear, pretty clear here at this point. Back to the function. So now we can go inside. We already saw collection size or default how it's working under the hood, and map index is the real method who is doing all the logic. So basically it's just like the same map2 function. The difference is only the transform, because now we have an extra parameter which is index. Otherwise trc c is basically we are also adding the constraint on this generic. This should be mutable collection, and it's expecting the r values, and then it's returning the c. And the new thing which we have in this method is index. So that is the differentiator between the map2 and mapIndexedTo. So here we are taking care of index separately, and every time when there is a loop, it's calling this index plus plus and check index overflow. Once this one is passed, they are pushing this value by using this transform, and then we get here in this example, just like I get here index and name, that is coming from this call, and then it's adding this value, the returning of this transformation into the destination. And I think we can go move towards the next method, not null. So what is the difference in this case? When we are calling this, or maybe map index to null, yep, we can start now this one. So again it's same, the difference should be same, just like in map not null, the transformation has the return value nullable. So in this case the transformation is still same, but we have the extra index which we already discussed. So how they are working here, but in this case there is no index variable available separately. Instead they are calling this separate loop, which is, it's a name only. We will go inside of this, and it's expecting a lambda which is saying index and element, and then in this lambda we are calling our lambda transform, and then we are checking the operation, and if it's null then skip, if not null then add this value. So what is this method? Perform the given action on each element, providing sequential index with the element. So for each indexed, basically I think I'm not sure, but most of the time I also use this method directly for each index. So they are using the same method which is already available. So in this case I'm expecting the same index. The difference is in this way, I will get the index and I will get the string, but this is not a kind of a map transformation. What I will do, that will be directly here. In this case I'm expecting to do a mapping, take that value, apply my transformation, and then return. And under the hood what they are doing, they are saying okay, there is an action index of type int, and then the value t, and then what they will do, they will only call that. So if we go again and review this, so in this case once this is map not null, they are getting the benefit of this already implemented function for each indexed. Once this is going to be called on this iterable, first time it will get from here. So I'm passing a lambda. Internally index is taken care by this method, and then they are only passing this index plus plus and item. So the question is, which is for you guys, why not they are implementing the same technique which they use in a mapIndexedTo function? So in case if you forgot, so in case of a mapIndexedTo, they are using directly the for loop and they are taking care of index on their own. But in this case, internally they are calling for each indexed, and then for each index is taking care of that index value, and then they are calling this. So now this is the question for you to figure it out. So I hope we learned something new today. See you in the next video. Bye.